Hi all, and welcome to a video after so long on Maneswar. And yeah, I don't even think I should call myself Maneswar or Captain X or anything like that because this thing is about static time theory. This video is about static time theory, and when I actually wrote the theory and the things that I'm about to talk in this video are regarding a time when I did not even had personal system like I have right now. This video is very emotional for me compared to my other videos on Maneswar. They are very topical and focused on stuff, majorly because it is about static time theory. Literally, I'm getting out of words talking about it. I will link Instagram post in the description if you want to go and read about it. I've written some bit about it, and rest I don't think I need to explain. It is the first thing that I ever did. I was in class 10th when I actually had the idea, and in formalization and writing part, it was 11th and 11th mid. And within a year or 1.5 years, when I originally had this idea, epiphany, if you want to call that, I left this whole idea and I moved on to uh, philosophy and computer science and left physics for like for forever. This was my last thing in physics, by the way. It is very nostalgic, emotional, and very different thing, and especially because it's been a decade. It's just, and on that note, only I am making this video. I am made this a rewritten version of the static time theory using Claude, and then for images I have used Gemini. Yeah, it was all just very emotional for me to do all of these things and finalize this, and I thought to do at least this much as a 10-year anniversary, as a 10-year thing. I don't know what to call it. You can see this on your image, the certification that I got at that moment. It is of 2018, but as I said, this was my final time when I stopped working on it. So actually the things that I did it in was 2016 was the time when I actually had this idea, but I started working on this from a more scientific perspective. Well, yeah, I don't know what else to say much. I'm just blabbing because actually I'm feeling very emotional from the time this got completed and the new version that I have seen of it right now. Like, yeah, when I wrote this for the first time, then I had this as everything, like the all paper, all scientific thing that I had. But now when I look into like 10 years later, a lot of things has changed, and I have one paper being published just, I guess, by the time this video is getting out on 2023rd June, it is getting presented in Belgium. Three papers are on me completed. I'm working on one paper for my AI in education stuff. Around like 8 papers that are going into processing right now, either completed or going through publication, or I'm working on them. And also, and I don't even consider such time theory as one of the papers right now that I have on me. Or, but yeah, I think it can be my zeroth index as as a scientist, so as a researcher in computer science field. It is very important to know that index starts on zero. So whenever I say I have 3 papers, then it actually means 4, because I always have this static time theory in background with me all the time. I am good enough proud of this. Although from a scientific point of view, now that I have done all this paper and stuff, I can see its limitations and how not that scientific it is, and some problems that I defined recently. But still, from a 10th class perspective, from a boy from 10th class, I can really see the rigor. I can see the passion. That's the important part. This video that I'm attaching after this thing is just a plain video made with notebook LM. So don't think of it as the final thing. Just think of it like a very rough trailer, and then go to the paper and read it. I have got a DOI thing and all. I will link that thing in the description. I will also link my website in the description. I would like you to go to my website first and then scroll to Maneswar and then read it from there. That is the way that I like to do things. But yeah, whatever you like. So yeah, well, that's all for this video. I hope you like this, and read the paper. And if you want to talk about anything, then you can find my email address on my website somewhere. So yeah, that's all. Yeah, it was really nostalgic, and I'm really happy that I did this. It's all not structured at this moment. It's talking from my emotions, and yeah, bye. Have a good day. See the video.
Welcome to this explainer. Okay, today we are taking a truly massive conceptual leap. We're going to flip everything we think we know about time and space completely on its head. And honestly, the craziest part? We're going to do all of this without changing a single established mathematical equation in physics. We are exploring the static time theory, which is this incredible reinterpretation of temporal ontology proposed by Madhusudan Pathak. Seriously, prepare to have your entire perspective of reality completely shifted. Okay, let's dive into the structural roadmap so we can unpack this massive paradigm shift step by step. We're going to cover 1. Inverting the flow of time. 2. Rethinking the cosmic origin. 3. Gateways, horizons, and matter. 4. Supertiming at quantum scales. 5. The sequential multiverse solution. and 6, the cosmic clock hypothesis. All right, starting with Section 1, inverting the flow of time.
First up, we've got to do a hard mental reset. For centuries, literally from Newton all the way to Einstein, the foundational assumption has always been that time is the thing that moves. We've thought of time as this flowing river, right? And the universe is just passively floating along inside it. But the static time theory, or STT for short, proposes a massive ontological inversion. What if time doesn't move at all? What if time is actually a static, eternally fixed pillar, a permanent substrate, and our entire three-dimensional universe is the thing that's physically moving through it?
And this brilliantly illustrates exactly what we're talking about. Contrast the two ideas. In the conventional view, time flows like an arrow past us. But in the STT model, time is a fixed line, and the universe is zooming across it through a higher dimensional medium called hyperspace. In this framework, we are actually traversing this static timeline at roughly the speed of light. In fact, STT argues that the speed of light isn't just a speed limit, it's the speed of causality. It's the fundamental speed at which our universe travels through the dimension of time itself. So if the universe itself is what's moving, what happens to space? Well, STT proposes something mind-bending. Physical space doesn't just exist as an empty, passive container. Space is actually an emergent property of the universe's motion. Think about that for a second. Space only exists because we are moving. When the universe accelerates its traversal through time, space expands. If it decelerates, space contracts. And if our universe were to, say, slam on the brakes and stop moving through time entirely, physical space would completely vanish, returning to a totally pre-spatial state.
You know, this isn't just abstract philosophy. It actually accounts for some persistent anomalies in modern astrophysics. Take the dark flow, for instance. This is a real-world observation where hundreds of galaxy clusters seem to be moving together in a single, massive, coherent direction. Standard models really struggle to explain it, but STT looks at that coherent galactic bulk flow and says exactly. That is observational evidence of our entire observable universe moving directionally through the temporal substrate.
Moving right along to Section 2, Rethinking the Cosmic Origin.
So applying this flipped kinematic lens completely redefines how everything kicked off. In the standard model, the Big Bang is a singularity, a moment where existence essentially popped out of nothing. But in STT, the Big Bang was not a creation event at all. It was an ignition event. Before the Big Bang, all the mass and energy of the universe actually already existed, but because it wasn't moving through time yet, it had absolutely zero spatial extent. The Big Bang was simply the moment the universe hit the gas pedal. It started moving through time, and as a result, emergent space rapidly ballooned outward.
Now this actually brings us to a really famous anomaly in physics called the Hubble tension. Basically, when we measure how fast the universe is expanding nearby versus far away, the numbers just don't match up. STT offers a really fascinating explanation for this. In this theory, gravity acts kind of like friction against our movement through time. So regions of the universe with less mass, meaning less friction, literally travel through the time dimension faster than heavily dense regions. And that difference in temporal speed completely skews our expansion measurements depending on where we happen to look.
Okay, Section 3, Gateways, Horizons, and Matter.
So, where does matter actually go when it falls into a black hole? It's the ultimate question, right? In standard physics, matter just gets crushed into an infinitely dense point. But if our universe is moving through a static timeline within a higher dimensional hyperspace, what does a black hole actually represent in all that motion? Let's see how this built, because in this theory, a black hole is literally a temporal gateway. Since we established that gravity acts as friction, the extreme gravity of a black hole actually slows down its local temporal traversal to essentially zero. At the singularity, space is completely eliminated, leaving behind only pure gravitons. Matter falling into a black hole accelerates so insanely fast through space that it breaks the temporal barrier, literally exiting our three-dimensional universe and slingshotting right out into the surrounding hyperspace. But wait. That matter doesn't just stay lost forever. STT proposes a coupled system utilizing white holes, which act as retrieval apertures. Out at the very edge of our universe, the particle horizon, dark matter contains pure antigravitons, and these antigravitons exert a repulsive space-stretching force. So white holes, powered by these antigravitons, basically catch the matter that was ejected into hyperspace by the black holes. They pull it back into our observable universe, which constantly stretches our cosmic boundary outward in the process. It's like a giant cosmic recycling system.
Section 4. Supertiming at quantum scales.
Now, what's really interesting here is how we shift down from the massive cosmic scale to the micro level. Have you ever heard of superposition in quantum mechanics? That's where a particle can be in two states or places at once. Well, STT introduces the temporal version of this, called supertiming. When tiny subatomic particles travel near the speed of light, they have so little mass that their temporal velocity actually equals or even exceeds the universe's own traversal rate. They break the temporal barrier, meaning they exist in two different moments of static time simultaneously.
This honestly brilliantly demystifies quantum mechanics. Take tachyons, for instance, those hypothetical particles that seem to move backward in time. STT says, no, they aren't time-traveling backward. They are just in supertiming, occupying two temporal positions at once. It also completely reframes Heisenberg's uncertainty principle. It's not just some fuzzy math problem, it's a literal ontological reality. You cannot determine a particle's exact position and momentum at the same time because its total lock of mass puts it in a literal blur across the static dimension of time.
Section 5. The Sequential Multiverse Solution.
Let's reset the narrative pace for a second to tackle the grandest philosophical scale you can imagine: multiverses and time travel. Instead of infinite parallel universes branching off every single time you make a choice, imagine a train moving along a single track of static time. Each train car is an entire universe, stacked linearly as temporal neighbors. Our universe is just one car. The one ahead of us is in our future, the one behind us is in our past. Because they are totally separate cars, if you travel back to a previous universe and change something, your origin universe remains completely unaffected. So the grandfather paradox, instantly resolved.
So how would you theoretically hop between these train cars? Well, STE outlines 3 specific navigation procedures. 1. You use the extreme acceleration of a black hole to break the temporal barrier and exit into hyperspace. 2. You traverse hyperspace and use a white hole of an adjacent universe as your entry door. Or 3. You somehow penetrate the super timing boundary of the particle horizon itself. Basically, it requires traversing hyperspace to move from our current temporal position to an adjacent one on the static timeline. Easy enough, right?
And finally, Section 6, the cosmic clock hypothesis.
We've made it to the grand finale. Let's combine everything we've covered into one massive, quantifiable prediction. Ultimately, the universe's motion is dictated by an epic tug-of-war. On one side, you have the space-contracting friction of mass and gravity. On the other side, you have the space-expanding driver of dark energy and anti-gravity. Right now, it's roughly a 30-70 split, meaning anti-gravity is winning. That's why our universe is accelerating through time and space, is expanding. But over billions of years, matter is condensing into black holes and dense remnants, meaning gravity's share of that pie is slowly but surely growing.
So, the absolutely crucial point is this. Eventually, gravity is gonna win that tug of war. Using a linear accumulation assumption, the cosmic clock hypothesis predicts that when gravity hits 100%, the friction will be absolute, our universe will slam on the temporal brakes. Based on our current 13.8 billion year age and that 30-70 ratio, STT predicts our universe will grind to a complete dead halt at approximately 46 billion years.
And all of this leaves us with a truly haunting, yet kind of beautiful question. If space only exists because we are moving through time, what happens at year 46 billion? When the brakes lock and space completely vanishes back into that infinitely dense pre-spatial state, is that just the end? Or does that massive compression trigger a new ignition, sparking a brand new universe to begin its journey down the static track of time? It really completely changes how you look up at the stars, doesn't it? Thank you so much for exploring the static time theory with us today.